Pretzel math time. Pretzel math time. Pretzel math time. Let freedom ring. So here we are at the cottage, about to do the math here. So this is it. Nice, awesome cottage here. And we're going to walk in, take a look around, and do some math. That's right. Yeah, pretty awesome, right? Nice, awesome math cottage here. Yeah, we are going to get some math done. Hello, and welcome to another great math cottage video. So here we are today. We're looking at page 12, problem 7. And what we're going to do here is we're going to be doing some factorization here, simplification. Now, first thing we're going to look at here is this middle term here, the 60c squared. And we know that that is 30c squared plus 30c squared. So that's what we're going to focus on, and we're going to convert that. And so we get, let's see here, we get 36c cubed plus 30c squared plus 30c squared plus 25c. This is all over 6c squared plus 5c. So that's what we got there. Now what we can do is we can take a 6c out of here, and then we can take a 5 out of here, and then we can also we do some other stuff too. But let's see here. Let's take a 6c out of here. So we get 6c times 6c squared plus 5c. This is plus, and we're taking the 5 out of here, plus 5 times 6c squared plus 5c. So we saw that 6c squared plus 5c is common here between these two expressions here, this one and this one. And then this is all over, all divided by, this is 6c squared plus 5c. So now, what we can tell here already is that we got a term. We're going to have a term that's common to the numerator and the denominator. And I'm going to rewrite this here. This is going to be 6c plus 5, and that is all times 6c squared plus 5c. All divided by 6c squared plus 5c. So you can see here that this 6c squared plus 5c, that will cancel in the numerator and the denominator, because anything divided by itself is 1. So like 7 divided by 7 is 1. X squared divided by x squared is 1. So now the answer here is going to be 6c plus 5, because that is 6c plus 5 over 1, which is 6c plus 5. So basically, the first strategy you want to use on a problem like this is to focus on that middle term and see if you can break it down into something that is able to be factored into something that looks like your bottom term. So that's what I did. Is I was looking at the bottom term. I'm looking at and I'm seeing, well, there's a 6 and there's a 5 there, and we see that they got some C's in there. So I'm thinking, maybe I can pull something out here that has a factor of 6 and 5, and put a 6 on one side and a 5 on the other. And the reason why this works here is because when we factor 60, let's see here, we got 60, that factors into 6 times 10, and 6 is 3 times 2, and then 10 is 2 times 5, and so basically this 6 and this 5, that would be, see here, a 5 here, and a 6 there, and then the 2 can go on either side, depending upon how this is going to work out here. So what I did there is I thought about it, and I'm like, okay, well, what we're going to do here is we'll do 30 times 30, and or not 30 times 30, but we'll basically, we'll just cut it in half, and we'll do 30 plus 30, and then we'll be able to factor a 5 out of 30, and we'll be able to factor a 6 out of 30, and then that's what we did. We factored a 6 out, and we factored a 5 out, and then we got 6 on one side, 6C, and then we got 5 on the other, and then we combined them here. So hopefully that makes sense to you guys. This is, I know, kind of challenging, but you might want to review this more than once and look at the strategy that we're going to use here, because we know that if we can cancel out the denominator and the numerator, then we're going to be left with something that looks like this, where you don't have a denominator anymore. And so, like I say, you're focusing on that denominator expression, and you're just kind of thinking, okay, how am I going to, pull something like that out of the numerator? And that's where factorization helps out some.